Hello students, so today we are going to discuss about the advantages of embedded systems and disadvantages of embedded systems. So definitely there are some pros and cons of the embedded systems and which we need to discuss here. So it is also important as per your syllabus and the as the part of the examination view. And here we have some pros of the embedded system, which is it is able to cover a wide variety of the environment. Okay, so it is a very good thing with the embedded system and less likely to encore errors. Second thing, embedded systems is simplified hardware, which is reduces the cost of overall. So overall cost of a system reduces when we introduce an embedded system in a large system. Offers an enhanced performance. So definitely we can have the enhanced performance using the embedded system. Embedded system is useful for the mass production, so we can produce a mass production. So for example, we have some media player, so we can make a mass production available for the embedded system. So it is not ordered based, we can produce number of large amount of the quantity of embedded system so that they can reach to the market. So embedded system is highly reliable because it is very small system and it is a very easy system, so it is very highly reliable and it can be used for longer time, and it has very few interconnections. The embedded system is small in size, so it is also the constraint of the embedded system, and we have to keep the size in a very small domain of the embedded system. And it has a fast operation, so time related real-time operation is important for the case of this. Offer improved productivity, product quality. So if we use a small embedded system for a large system, then we can improve the product quality. So it optimizes the use of the system resources. So and it has a low power operation. So these all things are related with the advantages of the embedded system. Another thing is the disadvantages of the embedded system. So according to this, here are important cons and drawbacks of using the embedded system. To develop an embedded system needs high development efforts. It needs to a long time to market because it is a custom design. So because we need to develop each and everything separately, so we have to, it is a long time to market. And embedded system to very specific task, so it cannot be programmed for the different things. Embedded systems offers very limited resources for memory. It does not offer any technological improvement further. It is difficult to backup of the embedded files. So these are all the disadvantages of the embedded system. So we have to discuss the design constraints of the embedded system. So what are the design constraints whenever we are going to design a system, embedded system? Then what are the design constraints for that? So here is the small size, low weight. So we have to force our system for the small size and the low weight, and these are the handheld devices and handheld electronics. So basically, for example, our mobile phone it is totally handheld device. It is a very good example of the embedded system, and mostly embedded systems are handheld. And transportation applications, weight cost money, and low power application, battery power for the more than 8 hours. For example, laptops often last for only the 2 hours, but the embedded system can work more than 8 hours. And limited cooling may limit power even if AC power is available. So this is a constraint. Low power is important constraint for the embedded system. Harsh environment, heat, vibration and shocks. This type of problem, this type of physical things should be our system can tolerate these type of physical problems, for example heat, vibration and shock. And power fluctuations, RF interference and lightning. So if there is a RF interference, for example if there is a touch sensor, then it is totally prone to the radio frequency interference. So if there is a radio frequency interference, then negative or false output may come from the touch sensor. So such type of power fluctuations and RF interference and lightning need to be considered. Water corrosion, physical abuse, so these type of things are need to be fined. safety critical operation must function correctly and must not function incorrectly. So it is important whenever any embedded system works incorrectly, then it may harm to a life also. For example, if it is a missile and if it is doing a function incorrectly, then it may be a very dangerous to the life of many persons. So extreme cost and sensitivity. So cost is important whenever we are designed to embedded system, because whenever a embedded system for is over there, then user don't want to pay so much for this, and it is a $0.05 to up to for the 1 million units. And some design challenges are there. Does it really work? Is it a specification correct? Does the implementation meet the specification? How do the test of the real characteristics? How do the test of the real data? So all these type of the questions we should know for the design challenges. So how do we work on the system? Observability and controllability. What is our development platform? So these things are important when we are going to design a challenge. And some design matrices are also there for the embedded system, and these are the common matrices are the unit cost. What is the unit cost of the system? What is the non-recurring engineering cost of the system? What is the size of the system? And what is performances of the system? What is power? The amount of the power consumed by the system. What is the flexibility of the system? So these things are important whenever we are going to design a embedded system. So you students should know these things professionally, and you should know that how we can use them for the designing of our embedded system. Okay, so this you will know about these things after only when you go through a particular subject, when you go through a particular area of the project. So you should build a project on your own self, then only you can design such type of system. So some common matrices are also there. Some time to prototype. So time to prototype to build a working version of the system. Time to market, that to develop a system to the point that it can be released and sold to the customer. Maintainability, how can I support this system after reaching to the market. Correctness, safety, and many more. So these all things are the design matrices. So there are some trade-off of the design matrices, and these things are power, performance, NRE cost, and size. So these are all the so if we force to the power, then performance and the size and NRE cost is suffers actually. So when we goes to the power performance, then power and NRE cost is suffers actually. And so for these things we have the design trade-off of in the design matrices, and we should find that how we can minimize them. So in the next lecture we will learn about typical architecture of an embedded system. So thank you for this lecture. So in next lecture we will find that what are the typical architecture of an embedded system. Thank you.